Now I'm going to talk about problems in which energy is conserved. Conservation of energy. When you're dealing with conservation of energy, you just have to remember that energy initial has to equal energy final. And then whatever energies you're talking about after that, you have to know the equations. So today, I'm going to talk about potential and kinetic. Potential energy's equation is mass times gravitational pull times height, and kinetic is 1/2 mass times velocity squared. So we're going to look at some examples. Say you have a car on top of a slope right here, and you have a flat area, and this is all frictionless. If the height right here is 2 meters, and we know the mass of the car is 100 kilograms, and we want to know how fast the car will be going at the bottom of the slope. How do we do that? So first we want to draw a bar graph showing our initial energy and our final energy. Initially, we're going to start out with all potential energy. The car is not moving, and it's above the ground. We're going to say the ground is this flat plane right here. We're going to call that 0. Then, at the end, we're going to have all kinetic. So, when we start, we'll write our equation. We know that initial has to equal final. So, we want mgh has to equal 1/2 mv squared. We can cancel out the mass, and then we can write in our values. So now we have to do some math. So we have everything as far as doing the math on each side of the equation. Now we want to get velocity by itself, so we multiply by 2 on both sides. And we get 39.2 equals velocity squared. And we do the square root of each of those. We get that the velocity down here, if this is all frictionless and energy is conserved, we get that the velocity is 6.26 meters per second. And that's going from potential to kinetic. But if we wanted to go from kinetic to potential, we would have to set it up a different way. So say we have that same car with a mass of 100 kilograms going at a velocity of 10 meters per second toward a hill. And we want to know how far up the hill the car will go if it just rolls up this frictionless plane. So we start by making our chart. We have all kinetic. And then we have all potential. So we say energy initial is equal to energy final. And we'll say this is a height of question mark. So we'll start by saying our initial is kinetic, so 1/2 mass times velocity squared is equal to mass times gravity times height. And we want to know the height that this car will go up the hill. So we start with writing in all our values. 1/2 times 100 times 10 to the power of 2 equals 100 times 9.8 times height. So then we write it out and simplify it even further. And then to get our height, we divide by 980 on both sides. And we get that the car will go about 5 meters up the hill if energy is conserved. And that's how you do problems with conservation of energy involving kinetics and potential energy.